This two-part video series is intended for sweet potato growers and producers in North Carolina. In Part 1, we learned how to identify symptoms of the guava root knot nematode and what to do if symptoms are present. In Part 2, we will discuss management practices for the guava root knot nematode that can be used on the farm. Guava root knot nematode is an aggressive plant pathogen of sweet potato, meaning it can multiply quickly and cause significant yield losses and damaged product. It is also difficult to control and eradicate once established in the field. Therefore, in terms of management, prevention is the best medicine. As a producer of sweet potatoes, you are in a unique position to combat guava root knot nematode through two disease management strategies. The first strategy is limiting the movement of guava root knot nematode from infested fields to non-infested fields. The second strategy is to reduce populations of guava root knot nematode that are already established in the field, as determined through soil sampling. Let's discuss the specific tactics that can be used within these two strategies. Because the nematode is very small, it cannot move far on its own. However, it can receive help from people to move around. Guava root knot nematode is transported to new areas primarily through the movement of infested soil and infected plant material. Infested soil is soil that contains the nematode, and soil sampling is used to determine whether or not the nematode is present. When infested soil moves to non-infested areas, the guava root knot nematode also moves with it, allowing the nematode to establish itself in those new areas. To limit the spread and impact of the nematode, reduce the spread of infested soil through sanitation practices. In the field, or at a designated decontamination site, remove soil stuck to tractors, trucks, planters, cultivators, diggers, and any other tools used after working in an infested field. Be sure to do this before moving to new fields, as you do not want to take the hitchhiking nematode with you. Use a power washer and a solution of 10% bleach and hot water. However, if you do not have this available to you, a strong blast from a hose is better than no washing at all. When working in infested fields, wear shoe covers or wash shoes and clothes to remove infested soil after finishing work. Planning out the order in which fields are worked can also assist in reducing movement of infested soil. Complete work in non-infested fields first, and hold off on working in known infested fields until all other work is done. That is, visit known infested fields last. This will reduce cross-contamination, or the chance that infested soil is brought into clean fields. Further, visiting infested fields last will minimize the amount of time and effort needed to sanitize equipment. The guava root knot nematode can also spread through infected plant material. Infected plant material is any part of living plants or field debris that contains the guava root knot nematode. This can include slips or sweet potato roots sold for seed, which may be infected. If purchasing sweet potato seed roots or slips, purchase and plant only certified material that has no symptoms of infection and is free of soil. If you are saving seed for use on your own farm, carefully inspect these seed roots for symptoms of infection and sample soil from seed beds for guava root knot nematode before planting. Any seed showing symptoms of infection should not be used. When cutting slips, cut them above the soil line and ensure that no soil or roots are present. Disinfect cutting knives before beginning work and periodically throughout the day with a solution of 10% bleach and hot water, rinsing well. Although these practices will require additional time and effort by producers and their employees, these short-term pains will promote long-term gains by reducing the likelihood that guava root knot nematode moves into new areas. In certain troublesome cases, sweet potato storage roots may appear clean at harvest, but then develop symptoms of infection in storage. This may be caused by second-stage juvenile nematodes entering the storage root just prior to harvest, and molting to the adult stage while in storage. Once at the adult stage, they produce noticeable symptoms of knots and galls. To avoid this situation, it is best to send soil samples for analysis to identify potentially infested fields and gauge risk of symptom development in storage. Many types of nematodes, including guava root knot nematode, are like flocks of birds or schools of fish. Individual nematodes tend to be found crowded together in patches within the field. That is, populations are often not evenly distributed over the field. These patches, or hotspots, are areas of the field that may have high nematode populations. The trouble, though, is that we don't often know if a field has a hotspot, and if it does, where it is located. Collecting soil samples in a zigzag or W-shaped pattern across the field will increase the odds of crossing over and sampling from a hotspot if present, leading to helpful detection of the guava root knot nematode. Further, because of this frequent patchiness in distribution, it may be helpful to section harvest of a field into subfield lots. When possible, section or separate the field into smaller lots and harvest one section at a time. Limit the size of each lot and keep them separated. That is, do not mix sweet potatoes from different subfield lots. The reasoning behind this method is that if one subfield lot contains infected sweet potatoes harvested from a hot spot within the field, there is a reduced risk of these infected sweet potatoes mixing with lots harvested from clean sections of the field. This can minimize the risk that the entire or total field lot is rejected due to guava root knot nematode infection. Lastly, do not leave infected sweet potatoes in the field, as this can provide a food source for the nematodes to continue feeding and reproducing. Because the guava root knot nematode multiplies quickly and has a broad host range, it is very difficult to fully eradicate or completely cure a field of infestation. However, there are a couple options available for managing the nematode. Review the results presented on your nematode assay report carefully. Your local county extension agent, crop consultant, or the North Carolina State University Plant Disease and Insect Clinic can help you with questions about the results. If guava root knot nematode is present, or if nematode populations are indicated as high, consider applying a chemical fumigant or non-fumigant nematicide. In sweet potato trials conducted at NC State University, sweet potato plots fumigated with Telone 2, followed by an in-furrow application of Vellum Prime, had significantly less damage when compared to non-treated sweet potato plots. When making applications of these, or any other fumigants or nematicides, be sure to read and follow all parts of the product label. Additionally, consider rotating to a poor or non-host crop, that is, a crop that does not support the feeding and reproduction of the nematode. By planting a non-host crop, this can assist in reducing the nematode population through starvation. Review the field history records to identify if other hosts of guava root knot nematode were planted recently. It is best to rotate away from sweet potato for 3 to 5 years to allow sufficient time for the populations to diminish. You'll recall that guava root knot nematode needs a host plant to feed upon and complete its life cycle. Removing infected sweet potatoes from the field and removing as much crop debris as possible will physically remove a portion of the nematode population from the field. This action will also reduce opportunities for the nematode to overwinter or survive the winter months in the field. Also recall that the guava root knot nematode is able to survive on many common weeds. Good weed management and removal of volunteer plants will reduce the food supply available to the nematode and slow its progress. The guava root knot nematode was reported in North Carolina in 2011, infecting cotton. The first report of the nematode on sweet potato in North Carolina was only a few years later in 2014. It has also been reported in Florida, South Carolina, Louisiana, Puerto Rico, and several countries worldwide, including China, Brazil, India, and Mexico. In North Carolina, the NCDA and CS has enacted an internal quarantine to prevent the further spread of this aggressive plant pathogen. Producers should become familiar with the requirements and regulations of the quarantine, and may do so by visiting the NCDA and CS plant industry website. Additional information and resources regarding the guava root knot nematode in sweet potato may be found at the websites listed here. Guava root knot nematode is a serious plant pathogen that threatens North Carolina sweet potato production. Agricultural scientists and extension specialists at North Carolina State University continue to investigate management solutions. With your help, we can reduce the impact of guava root knot nematode on sweet potato in North Carolina.